So after doing a couple specific examples, let's try to generalize some of these behaviors across all four of our quadrants. I'll just do a little sketch. I'll try to make it decent size so we can try to fit some information on here. Right, in counterclockwise, right, starting here we hit quadrant 1, then to quadrant 2, quadrant 3, and quadrant 4. And so what we're basing this on, right, so point P is xy. We know x squared plus y squared is r squared, and then the associations here, right, are that the x value is going to be our adjacent side, the y value is going to be our opposite, and the r value is going to be our hypotenuse. So let's just sort of take a minute and let's go all the way through here, and let's, in particular, we're really just trying, obviously we're going to have like different values in each of these quadrants, so some more what we're looking at is the sign, positive or negative. Quadrant 1, right, x values are positive, y values are positive, r is always positive, right? So what's happening for us here, if x and y and r, all of the individual terms are positive, so then all of our trig functions will be positive, right? I'm going to just sort of do this from the perspective of the big three, sine, cosine, and tangent, and I'm going to assume that we're all good to go as far as extending that to the reciprocals, cosecant, secant, and cotangent. So in quadrant 1, everything is positive. We were sort of doing this in the last section, right? Whenever we sort of draw our right triangles and work with those interior angles, we're kind of doing this even if we're not necessarily drawing those angles in standard form on the xy plane. So things will start to get a little bit more interesting in the second quadrant. So what changes? So the x value is negative, right? As we go to the left, we're still above the horizontal axis, so our y value is positive, and we've kind of said that our radius values are always positive. So what's going to be going on here? So in this case now, our sine function, because sine is based on the y and the r, sine is still going to be positive, but the cosine value is going to be negative, right? Because cosine is based on the x and the r. And then the other thing that's going to happen is that our tangent, because it's a mixture, right, the y value divided by the x, tangent is also going to be negative. So the positive sort of pair, sine and then cosecant, are going to be for quadrant 2. So in the second quadrant, sort of two of our big three flip to negative. Sine is the only one that stays positive. Quadrant 3, keep this going. So in quadrant 3, both the x and the y are negative. The radius, as always, is still positive. What does that mean for us? Well, so our sine function based on the y value would be negative, right? Cosine, which is based on the x and the radius, is going to be negative. Tangent, that right we saw was the y value divided by the x, is in some sense a double negative. So our tangent function actually becomes positive. So what's happening for us here as far as the big three go is sine and cosine are negative, and the tangent function is the one that's positive. So there's a little bit of a change. You can kind of imagine as we sort of shift through these different positive or negative x values, they're having these effects on our trig values. Last but not least, quadrant 4, we're shifting sort of back around. So now the x's have shifted to the right, so the x's are back into the positive direction. Our y values are still negative because we're below the axis, right, the horizontal axis. The radius, as always, remains positive. So what's going on with our functions? Well, the sine value, because it's based on the y and the r, sine is still negative. Cosine theta is based on the x, so cosine is now back to being positive. And then tangent, because it sort of is a mix of the two, the y and the x, or you can think of it in terms of the sine over the cosine, is going to be negative. So in that fourth quadrant, it's going to be out of the big three the cosine function that's positive. And again, sort of by extension, it's going to be our secant function, right? So I'm doing the big three here and assuming that we're going to carry these properties through to our reciprocal functions. So this is sort of, as far as the positives go, all positive in the first, sine is positive in the second, tangent is positive in the third, and cosine is positive in the fourth. What you see sometimes people write out is they sort of go, right, A for all, S for sine, T for tangent, C for cosine, right? So working through the quadrants. And I've heard people say, you know, a smart trig class, a spectacular trig class, different things like that. A super tricky cat. You know, any kind of thing that you want to make up, any sort of silly phrase works here. So this is pretty good. This is something that sort of helps us figure out. In each of these quadrants gets a little bit of a pattern going as far as, so what are these different values, positive or negative for each of these. What's going to start to happen, you can kind of imagine, you know, our xy coordinates in particular, once we start to associate them with particular angles. The sort of xy pairs will kind of repeat, right? You could have sort of a positive 2 and a positive 3 versus a positive, or a negative 2 and a positive 3 versus a negative 2 and a negative 3 versus a positive 2 and a negative 3. You can kind of have 2s and 3s that all give you the same radius, and you're just sort of flipping the signs around a little bit as you circulate through all these positions. So what will happen is we'll see a lot of the same types of fraction values from our trig functions. It's just sort of the positive or negative aspects that are changing. Another thing we can do from here is we can do the trig functions. So we can start to sort of build up and get trig values at the quadrant angles. So our quadrant angles are sort of versions of 90 degrees, versions of pi over 2. Shift this up a little bit. I'll draw another quadrant here. Right. So we sort of have 0 degrees is 0 in radians. What we can do if we start to sort of pick some points on the axis, right, x and y. So 0 degrees, in some sense, right, 0 radians. We can't really draw a triangle here, right? There's not really a way to do that. In some sense, what's happening is you would have a triangle that was sort of like this, and it would get flatter and flatter and flatter, and I guess in some sense the radius and the adjacent sort of sync up, and then the opposite side shrinks down to 0, at least at this position. What we can do is essentially just pick the nicest possible coordinate on the x-axis, and so what we'll do to sort of make our lives easy is we'll just use x value +1, and then our y value is 0. So at 0 degrees we can kind of use the point 1, 0. When we do this, one of the things that will happen is our radius value will be 1. We'll come back to this in a minute. Let's get these guys all labeled up first. So 90 degrees would be our sort of next quadrant angle, right? If we put a point up here, so 90 degrees, this would be pi over 2 in radians. As far as having kind of an equivalent nice point, so this would be sort of 0 in x, and then +1 in my y values. And you can imagine sort of just keeping this going, right? So 180 out here, which would be pi in radians. So what starts to happen now is, so this is -1 in the x and 0 in the y, and if I go down here, 270 degrees, which would be 3 pi over 2. So that's going to leave me where 0 in the x and then -1 in the y. If I go all the way around, right, this would be 360, or 2 pi, and then of course it would continue moving. So I can use, right, my point is like xy, is sort of a version of 1s and 0s. What will happen, so at each of these positions, our radius is going to end up as 1, right? So if I do sort of, you know, x is 1, y is 0, 1 squared plus 0 squared is 1, the root of 1 is 1. 0 squared plus 1 squared is 1, the root of 1 is 1. The negatives, right? Negative 1 squared is 1, plus 0 squared is 1, the root of 1 is 1, and so on and so forth. So what this means is if I kind of have these points as a reference and I know my radius is 1, I can pretty quickly find trig values at these quadrant angles, right? Just using the sort of x and y values from the coordinates and then just using radius 1. This is kind of leading us towards our unit circle, which is going to sort of build off this principle of the idea of having sort of coordinates, xy coordinates, where the radius is 1. Those would be points on what we call the unit circle, a circle with radius 1. That's going to be what we talk about in setup in 5.4. So this is a little bit of a sort of look ahead. In any event, we could sort of do this now. So if I wanted to do something like, right, the sine at 180 degrees, right? So that should be the y value divided by the radius. At 180, what's my y value? My y value is 0, and my radius is 1. So I can pretty quickly get to that trig function, even though I don't really have a great triangle that I can draw. I've sort of, you know, at these quadrant angles, my triangle picture kind of collapses. So I'm leaning really just on my kind of x and y and r definitions. But it works, right? I mean, we sort of set this stuff all up, so we should put it to use. Let's do just another kind of quickly, do some radian ones, right? Tangent 3 pi over 2. So tangent is supposed to be the y value divided by the x. 3 pi over 2, right, is here at 270, 3/4 of the way around. So this is the y value is -1, divided by the x value is 0. One of the things here that's interesting, right, so we have kind of a 1 coordinate and a 0 coordinate. So what can happen for some of these functions is I can actually end up dividing by 0, which of course is going to be undefined. So some of these trig values at each of these quadrant angles, when I sort of fix one of my x or y values to 0, I'm going to get undefined values. There's not really any sort of working around it. It's just something that will happen. Let's do secant at 90 degrees. Secant, right, we're flipping the cosine around, so that would be my sort of radius value divided by the x. Oh, we're going to do another one straight away, right? So the radius is 1, my x value here is 0. So not even just tangent or cotangent, even something like secant, right? If you're dividing by the x and the x is 0, that's also going to be undefined. This is sort of making it seem like they're all going to be undefined. Let's see if we can fish for a -1. How about cosine at pi? So cosine should be the x value divided by the r. So our x is -1, the radius is 1, and we end up at -1. You can kind of expect, right, all these values will be one of 3 things. They'll either be, well, or 4 things. They'll either be 0, if you have a 0 on top. They could be positive or -1, right? If you have sort of a positive or -1 over the radius, and the radius is 1. Or they could be undefined if you're ending up dividing by 0. Those are going to be sort of all of our possibilities. So if we have this quadrant set up as a reference, you can find these values pretty quick. Again, this is a little bit of a precursor to working with the unit circle, which is going to be sort of taking this idea and extending it not just to these particular quadrant angles, but out to some of our more common angles like 30 and 60 and 45.